Good afternoon, everyone.
皆様こんにちは。衛星VDES国際フォーラム社会実装に向けた取り組みと今後求められる国際協働についてを始めたいと思います。海外からのお客様ご歓迎申し上げます。非常に素晴らしい機会となりました。まずイベントの開始にあたりまして坂口所長、海洋政策研究所、笹川平和財団海洋政策研究所の坂口所長、お願いします。
Thank you very much for your introduction. As was introduced, my name is Hide Sakaguchi, President of Ocean Policy Research Institute, Sasakawa Peace Foundation. Very good to see you here. Good afternoon, and also good evening, good morning for the participants from all over the world. First, I would like to express my sincere gratitude to IALA for organizing the workshop about maritime digital communication. And I also would like to express my gratitude to the Japan Coast Guard for coordinating the event in Tokyo Hall this week. Thank you very much. And I specifically appreciate Rear Admiral Tsuguo Awai, Director of the International Maritime Security Group in Japan, Coast Guard, and IR Counselor for Japan, to deliver his keynote speech in this forum. I also would like to thank all the other speakers and the participants from overseas and from Japan. As many participants may already know, Satellite VDES, which is today's theme, is a new maritime communication infrastructure known as Next Generation AIS. Consequently, Ocean Policy Research Institute, which I'm directing, aims a future goal of promoting the use of satellite VDES for the safety and security of all people at sea, and eventually equipping all ships with VDES, which is not obligatory under the SOLAS Convention. In this regard, we, Ocean Policy Research Institute, have been conducting various activities such as policy proposal and also establishing a mechanism for wealth distribution of VDES and holding symposiums, also having discussion in committees. While in Japan, the government is just beginning to pay attention to the usefulness of satellite VDES. The construction of a satellite constellation, including VDES satellite, has been identified as a research and development agenda for the key and advanced technology R&D through cross-community collaboration program, which is KPRO in short in Japan. In addition, several organizations, including Ocean Policy Research Institute, submitted recommendations describing satellite VDES toward the revision of the fourth basic plan on ocean policy, which guide the direction of the national ocean policy for the next 5 years. Although the purpose of this forum today will be introduced very shortly, the aim is to discuss and to share the challenges and potential cooperation on future international coordination, as we are all aware, toward the social implementation of satellite VDES. International cooperation is one of the key factors which is essential to make VDES a common maritime communication infrastructure that can be used worldwide. In this context, with this launch of the Satellite VDES Consortium in Japan and the VDES Alliance in Europe, this gathering of maritime digital communication stakeholders for the IALA workshop is a unique opportunity to discuss future international collaboration. I really hope we can encourage all participants to freely exchange ideas, information, and opinions, and we'd love to have your input from the floor as well as from the stage. I hope this forum will be productive and fruitful for all of us. Thank you very much.
Thank you very much, President Hide, for your powerful word and passion toward Satellite VDES. Sorry to introduce myself. I am Kotaro Tanaka, a research fellow of Ocean Policy Research Institute and the general MC of today's forum. Here in Tokyo, we have close to 100 participants in this room, and also we have 100 people plus online. So I do appreciate again for your participation and having interest on the Satellite VDES and this forum. Thank you very much. Now I will introduce, as an organizer, we will introduce the purpose of this forum from Dr. Tomonari Akamatsu, a director of the Division of Ocean Policy Research of OPRI SVF. So Dr. Akamatsu, please take the floor.
Thank you so much, all. And really thank you so much for the Japan Coast Guard, especially for the Awai Sensei, and also the other staffs, and also the worldwide really distinguished participant to coming to this forum again. My name is Tomo Akamatsu, and I'm kind of tour guide for you, and also director of the research division of the OPRI. And let me introduce what we, the OPRI, doing for the promotion of the Satellite VDES, and also the kind of the scope of today. So please, next slide, please. Yeah, this is some kind of cartoon. There's a lot of things happening in the ocean. The many traffics from the cargo ship and the fishing ship, and many other even the animals and buoys and submarines. And we need to govern, we need to control them for the primary safety of the marine traffic. Next slide, please. So many issues and many challenges existing. For example, like avoiding collision or the local port service, or even more broader, the maritime domain awareness. And that is the kind of the world agenda for the governance of the ocean these days. And not only for the maritime, but also fishing and even the weather, and also the protection animal. These are also within the scope of the VDES system. Next, please. To do that, we are doing lots of activities. In the beginning, nearly about 10 years ago, we organized the something like forum to discuss what we can do that. And it was happening in 2012. And we continue that kind of discussion and extensively start discussion and organize a study group since 2018, about 5 years ago. And as you see, the many study group, not only for the technical group, but also the use case group organized. And we published that in, in Japanese, in web page and open for the public now. And now it is a time to shake hands, not only inside Japan, but also many other countries like you guys. And I think this year is kind of the digital communication, start of the digital communication in the maritime affairs, I think. So next, please. So one of the example is our idea is a mutually coordinated navigation using satellite VDES. That is one of the kind of business case or even the application. These days, the ship-and-ship communication by using the voice and okay, I'm here and you're there, so I gotta avoid it. And that kind of the system can be automatically be done in the future. Future means very near future. By using a VDES system, then the ship-to-ship communication can be nearly automatically done by communicating machine to machine. And machine let the captain or crew knows or what's going on outside the ship. As you saw in the beginning of the cartoon showing in the screen, and that is one of the case of the avoiding a big ship of the fishing gears. And that kind of automatic warning or automatic avoiding behavior can be controlled or can be advised by the VDES system in the future. Next, please. We are the think tank, and not only for the maritime application, but we are focusing on the blue economy or blue carbon, biodiversity, or the fishing control and preventing the IUU fisheries. So many, many issues exist in the ocean. Now, the overfishing is a very important and serious issue, especially in the Asian water. But the food security is one of the very important issues for all of the country now. And the VDES system is not only applicable for the maritime safety, but also to see the monitoring of the fishing activities and also the certification of the fishing activity at a specific location and targeting a specific species with a load amount. Not only the fisheries, but also the climate change that is global agenda now, and to measure and monitor how much the water temperature elevate, or even the biological products in the ocean can be monitored by using lots of vessels, the shipping around in all over the globe. Marine pollution, that is also the big issue, especially for plastic, and also the reduction of biodiversity, that is also quite serious issue, especially in tropical waters. And these issues also need something, the sensing and communication methodology. And VDES is one of the very reliable and important infrastructure in the future for the monitor of these kind of issues. Next, please. And our output of our activities by far 10 years, especially in these 3 years, we issued a policy brief and promotion video and cartoons you saw in the beginning, and also the symposium of the VDES promotion, and including this international symposium. And now, many guys didn't know the VDES before, about 3 years ago, but now many guys start to understand, and see the VDES may be quite useful for the marine domain awareness, and especially for the maritime safety. Next, please. And our outcome is already that President Sakaguchi mentioned, the Japanese major policy making and also the outcome of it. We will have a big funding for the satellite VDES launching and also the application and promotion of the VDES communication. And also we launched the consortium, the Japanese consortium related to the VDES satellite, but also the communication use case, gathering more than 10 companies, including our foundation as well. And also we keep discussing with you guys on the IALA platform, enough, and also the workshop in this week. So this is the time we can implement these kind of outcome in the real policy making and promoting of the VDES system worldwide. Next, please. Our future plan is like this. It's a little bit complicated, but we are the think tank. We are the bridge to connect with the science and technology to the policy making. So the science and technology side, a lot of new technologies and new protocols are provided. But for the policy maker, needed to know how we can use it and what that VDES system can contribute for the future making. So we knew both, even partially. So our role is to bridge between the VDES hardware, software, the technological side, to the international bodies and also the domestic regime and policy making. So this is the things we need to tackle on the next couple of years. Next, please. So finally, what we wish to today is 3 things. Simply saying, we're going to find allies. This activity is not only domestic. This activity should be international and shake hands each other and to have protocol standardizations and data management, and also the use case promotion and blah, blah, blah. Many things can be done only by the international alliance. And also the shared challenges, not only for the satellite, not only for the receivers, the different sectors, including government, and different perspectives we need to include. And not only technical aspect, but the social, operational, and commercial aspect is needed. In that case, not only the global scale standard, but also the regional law or regional rule may be implemented for each sectors. So let us exchange the idea about the future potential collaboration, domestic bilateral, multilateral opportunities during next couple of hours. Thank you so much. So let us start for the next session. Thank you.
Thank you very much, Tom, for introducing OPLI's activity and also clarifying the purpose of today's forum. Now we would like to have a keynote speech from Rear Admiral Tsugo Awai, Japan Coast Guard and IALA Counselor for Japan. So Admiral Awai, please take your floor.
Thank you for the kind introduction. I'm not going to say too much about myself. We are already familiar to each other in the previous program in the last 5 days, but I know that there are many more people joining the program online, so thank you very much for coming over. Well, normally the Friday afternoon is a time for shopping, but for all of you who have finished the 5 days program in the Tokyo University of Marine Science and Technology, once again, thank you very much for coming over and continue to work with us. I have prepared a few slides, but I'm not going to explain each of these slides. I've just listed the keywords which the VDES development is looking at. So I'm not going to explain these things, just the keywords for you to understand what I'm going to say. VDES, which is being developed as a new next-generation maritime infrastructure to replace AIS, is primarily intended to improve the vessel traffic, safety, and maritime activity efficiency. However, its versatility and scalability are expected to have more innovative strategic maritime possibility that can be leveraged beyond original purposes. For example, discussions are about to be made in IMO on the possibility of simplifying the GMDSS, which has implemented numerous functions individually by separate radio equipment to efficiently realize more advanced maritime safety environment with a single piece of equipment, which, if realized, would result in a very different maritime safety system. When a GMDSS was conceived, the world had no internet, no smartphones, no cloud technology, and the shipborne system was simply a collection of conventional radio equipment. Nowadays, the environment for system development is totally different, not to mention smartphones that can control many different applications on the palm top. Although VDES shipboard equipment is one type of radio equipment, there are sophisticated IT infrastructure behind the system. The time has come to realize a seamless advanced information communication environment to connect the sea and shore services by utilizing cloud technology, etc., and to extend the scope to the countless general smartphone users ashore. Further, the Maritime Domain Awareness, or MDA, the core concept of modern maritime security, aims to visualize the oceans and suppress transboundary crime, IUU fishing, environmental destruction, etc. by monitoring the movement of all maritime activities, and the VDES will no doubt be one of the new foundation for MDA. AIS indicates its presence to the nearby vessels and receives signals by satellite. The shore authorities are able to receive the signals by satellite to achieve wide area situational awareness. VDES takes over this functionality and attempts to realize even more sophisticated functions through ASM and VDE, making it a unique and original system that integrates ground and satellite systems. For the new system to be effective, it must be spread not only to the tens of thousands of solar vessels worldwide, but also to the millions of fishing vessels and small pleasure boats. This is very important from the MDA perspective of eliminating unknowns from the maritime domain and making it transparent. The VDES should have the potential to be widely used in the society by taking advantage of its multifunctionality, flexibility, and expandability to achieve not only the safety but also comprehensive social convenience. For shore users, so this is what we mean by seamless. And for this purpose, it is necessary for many stakeholders beyond the maritime community to participate in the project as unique stakeholders. And what we need is to build a such critical strategic infrastructure covering the entire world is to harmonize, and the word is harmonious and efficient international cooperation. With the many environmental, population, energy, and food supply challenges the world is facing, public and private stakeholders must join forces and collaborate to take on these challenges in order to realize a sustainable world. The development and implementation of VDES, a new strategic infrastructure for the sea, which is responsible for most international logistics and place to secure food through the secure food through the fisheries, is something the world should work in the spirit of cooperation. The goal 14 of the SDGs, adopted by the United Nations in 2015, is to maintain a rich ocean by protecting its resources, environment, and biodiversity. The numerous VDES applications and use cases presented at this forum will have the potential to contribute to SDG 14 by using the ocean in an environmentally friendly, safe, and efficient manner, which is why we must realize VDES through international collaboration. This is almost obvious given the VDES mission of next generation's public infrastructure covering the ocean through space while maintaining compatibility with AIS. I mentioned the GMDSS at the beginning of my speech, and its core value or core system, the COSPA-SASAT, is a global search and rescue system in which each country provides a compatible space segment and ground segment that work together. Especially in the MEUSA system, the multiple constellations of GPS, GLONASS, and Galileo covered the entire globe with high redundancy and reliability, and such a cooperative system may provide a hint for the direction of VDES implementation. On the other hand, the GMDSS took a different path to full implementation, as discussions on safety and cooperation have been sidelines to a certain extent in favor of other objectives than the original purpose of the GMDSS, which was to reduce the number of seafarers so that the developed countries, shipping countries, could compete with developing countries in terms of cost. In addition, as companies competed in the narrow market of the solar vessels, equipment prices became more expensive and systems became more complex, subdivided by functions. While VDES seeks to contribute to digitalization at sea through its multifunctionality and scalability, ship operations are not completed at sea, and safety and efficiency are achieved in a seamless relationship with shore services. VDES will also demonstrate its true value when used not only by solar vessels, but also by all vessels as a seamless infrastructure linking the sea and shore services, and the market is expected to expand to both domains. This requires stakeholders to cooperate to achieve a system of excellence towards a common goal while maintaining sound competition. In commercial business, sound development will be achieved when both competition and cooperation coexist. In this context, the purpose of this forum is to discuss what international cooperation is required for the new maritime infrastructure of VDES and what the stakeholders with different positions should do. Players in various countries are already actively engaged in various activities, including the development of maritime equipment and the launch of satellites already. It would be a meaningful meeting if we could discuss future issues and possible future collaboration, including the activities and future plans of the participants. We look forward to active discussions among participants from various fields. Thank you very much.
Thank you so much, Admiral Awai, for introducing the horizon of Satellite VDES and also stressing the importance of international cooperation and collaboration. Now is the time for the panel discussion. So, distinguished presenters, please go up to the stages, please. To the stage, please. We are going to have a first session of the panel discussion. It is about construction of infrastructure and system. In this session one, we will discuss the establishment and maintenance of infrastructure and systems for Satellite VDES. And from now on, I will hand the lead over to Mr. Nishimura, who is the moderator of this session one. So if you're ready, Mr. Nishimura, please take your floor.
My name is Nishimura, Koichi Nishimura. The foreigners call me just Koichi, but let me see. I come from TSA Corporation. TSA Corporation is act as a port BTS, and we provide local port services in major Japanese ports. And Satellite VDES is it's a very important communication tool in the future. So I will take part of the moderator of session one. Well, so the first speaker is Lars Mortensen of Standard. Standard means common Japanese people and some others don't know about standard, the terms of standard, but the term standard means a real word. But, Lars probably explain about this, but the standard launched first a commercial VDES satellite on the 3rd January this year. And we probably have a very interesting story about this. And it's a very first ever information for all stakeholders in the world. So, Lars, the floor is yours, please.
Does this work? Yeah. はじめまして。私はラス・モルセンです。スタノラの創設
I'm a founder and CEO of Stanola.
People here are English speaking. I will switch to English again now. Okay, so welcome to my presentation. I'll just introduce both VDES to some extent, or AIS 2.0 as we call it. I will introduce Stanola, the company. I may add that the name of the bird that Stanola represents is in Japanese the ko-ashisachi bird, which is a small seagull which flies very much north and south. So when we were planning the launch of our first satellite, we knew that we were going to target this polar orbit. So because of the satellite is very small, and because it flies north and south, we named the company after this bird. Okay, so our slogan is connecting the oceans. So our vision was more than just flying satellites. We wanted to exploit this technology that was under development already when we started the company 4 years ago to be able to connect the oceans. But there's much more to that than just the VDES and the AIS 2.0. But I'll get back to that. First, I would just like to show you the very fantastic day we had on the 3rd of January when our first satellite was launched. So that should be right here. Oh, I have to press this one. So this is the SpaceX launcher in Cape Canaveral, Florida. So it was a very, very exciting hour.
Merlin 1D engines in preparation for stage separation.
And that's
ISI launched Sternula 1, separation confirmed.
Yeah, so you can imagine it was a very, very intense hour. It took 1 hour from the launch until they made this little announcement, Sternula 1 ejected from the SpaceX launch vehicle. Okay, so going a little bit back to the technology, I just wanted to recap. We have talked about it already, but AIS 2.0 or VDES is this extension of what we call AIS 1.x. It's AIS is this technology which is a global standard and which was meant for digital exchange of identity and position of ships more than 20 years ago. It became a global standard with the ITUR 1371-1 in 2001 already. It also became a SOLAS requirement for ships, so ships of a certain size has to carry this. And yeah, as you can see here, it's quite a simple system, but very robust and very powerful. It enables ships to exchange these identities and positions, and also share it with coast radio stations, and later came also the reception from satellites of this data. AIS 2.0 is more or less the same in architecture, just more radio spectrum available, more efficient data channels. So now you can, in fact, transmit more than 30 times the data that you can in the old system. And then you also have the satellite downlink suddenly, so you can communicate two-way with the ships from satellite. And that is where we decided to fill a gap in the ecosystem. So that's why we started Stanola this 4 years ago. And just a little note on why we use both AIS 2.0 and VDES is that VDES is the correct name, as we already saw. Despite there was this next generation AIS name also used in the beginning, but AIS 2.0 we learned is just much more efficient to say when we talk with people in the maritime industry who knows about AIS but who has not heard about VDES before, because then the logical next question to them will be, okay, so what is the new part? And then conversation is moving forward much faster than if we start talking about VDES, which is completely unknown. So it's a little bit like using 3G, 4G, 5G in the mobile domain. And then shortly about Sternula. We have decided that we wanted to be this leader in AIS 2.0 and VDES. So my colleague and co-founder of Sternula, Stefan Pihlmeier, is the chairman today of the IALA Working Group 3 on digital communication systems. We also became a co-founder of the VDES Alliance recently. And we also act very much as an advisor to Danish authorities, both in the frequency domain and in the maritime domain. And then, of course, we became Denmark's first satellite operator and also the world's first commercial VDES satellite operator on January 3rd this year. So, when can you expect VDES to be a technology that you can make use of? Well, you can already start using it now, since we have the satellite up flying. We also have the, the NorSat 2 satellite flying for a couple of years from Space Norway. So you can start doing your tests already now. You can do pilot projects from the satellite links. In time, you will also get coast radio stations built in the region here, of course, also. It will take a little while before they are all available. So it is actually, in fact, better to start from the satellite and then go for the coastal radio installations as the supplement when the real takeoff of the technology is there by many ships being connected. So we can say that the satellite VDES is already here for pilot projects. The sort of addition of coastal radio installations depend on the local maritime authorities, but could be expected in many places around the world in 2026. And the devices, of course, on the ships. Today there are around 250,000 ships with AIS installed. We expect this to grow up to around 1 million in 2030. And that's partly because of VDES, because where AIS is a mandatory system that is helpful, but to some extent a burden to, for instance, the fishermen, because they don't necessarily want to reveal where they are. VDES gives them a lot of data services that they really need and want. So that's why the growth will continue. And there are 3 million fishing vessels in the world, so there's a large potential for this continued growth. And by 2030, the 80% should be AIS 2.0. Yeah, and that means that you can actually start thinking about this as the world's largest maritime communication system. And then last from our side is just to show you what our plans are for expanding our satellite network. So we have our first satellite in place. We plan to launch another 4 satellites in 2024. Maybe it will be 2025. It depends a little bit on how fast we get the new investors on board that we need to do this. Then we need another 16 satellites in 2026 and 40 satellites in 2028, which gives us the 60 satellites that gives us global real-time coverage, which is needed for some digital services. In parallel, we'll be working with roaming between governmental satellite operators and also private potential competitors. We can do roaming, and we are already starting to do that together with Space Norway. Thank you.
think all participants in the forum and online participants may have a question, but I'm going to take the opportunity to ask a question to speakers afterwards. So next, we have two speakers, my old friends, Peter Bergen and Magnus Nyberg from Saab. Saab has been a pioneer since the days of AIS, 0.0 and 1.0, and we have interesting things to say about AIS 2.0. Peter, you have the floor, please.
Magnus will start.
Oh, Magnus, yeah. Okay.
Is it on, the presentation? Thank you very much. My name is Magnus Nyberg, and I think I'm the person that has been working with AIS the longest in this room, I think. But so I will present a little bit about what Saab is doing regarding VDES and also our products. And then I will leave over to Peter, and he'll talk about our satellite payloads that we are building. Yeah, Saab Transponder Tech has been in the business for a long time. Saab's AIS business is actually originated out of the Swedish Space Corporation. So that is where AIS was born one time, if you go back in time, 1995, 96, where we built the first R1 transponder. And I'm going to present where we are now. We have actually passed R1, R2, R3, R4, R5, and now we are in the R6 generation, where we are also introducing VDES as a layer on our transponders. So the transponders are mainly built to be AIS transponders, but with a license we can open up both ASM and VDES or VDE. So this is the hardware that we have today. We have the ship transponder that was type approved for AIS this year in September. And then we have the shore station that was type approved for VDES, for AIS in 2020. So that has been on the market for some time. We have delivered a number of test beds so far for VDES, where we are delivering the hardware with VDES license, where we have limited, test capability, or I wouldn't say limited test capabilities. We have test capabilities where you can actually test the various link IDs. So we have implemented link ID 11, 17, and 19 on the terrestrial VDE, so we can do both the wide band, the high data rate messages, and also the low data rate messages. And then we have also done an integration with the first service provider of VDES, Lars, so we can communicate with his satellite. So our ship transponder can be used both for the satellite trials regarding VDES, but also for terrestrial trials. So we have implemented handshaking, retransmission, resource request, and the bulletin board. So there is possibilities to actually test real communication through the VDES system. So this is the development path that we have had. So our space IOD is actually originating out of our technology that is coming from our ship transponder. So it's the same software-defined radio technology that everything is based on. And also now we are in the queue for launching our satellite VDES transponder, and Peter will talk more about that, but we have passed all the testing for it, and it has also been sent for launching. Peter will talk more about that.
Yes, my name is Peter Bergung, and I will talk a little more about our first talk about our IOD project, our in-orbit demonstration VDES satellite that is supported by the Swedish Transport Agency. Our vision here in the VDES Consortium, that is ASC Clyde Space, Orbcom and Saab joined together, sending up what we call the NJORD-1 satellite. And the vision is to create a global maritime communication system, enabling great improvements to seafarers. Of course, we will also doing roaming with other satellite VDES manufacturers. And what we are now doing is building and launching our first satellite. And it is expected to fall by a large constellation, but we have no decision yet. And the time schedule is that we're going to go with the Transporter 9 mission. Standard was going with the Transporter 6 mission. And our VDES IOD payload will be placed into orbit, scheduled for launch the 17th of November this year. And as Magnus was saying, we are already delivered the IOD payload to the satellite company, ASC Clyde Space. We did that already beginning last year. And then you can see 4 pictures here. First, a hand palm with a payload, 500 gram. You can have it in your payload. And then on the right, you have the 3U OSEA Clyde Space satellite with an extended Yagi antenna. And then you have a closed in of the VDES IOD payload with its antenna interfaces. And then you have a close-up on the special Yagi antenna that we are using. We have put a lot of emphasis on the IOD payload interface. We have an antenna interface for vertical and horizontal polarization. You can see the antenna interfaces and the attenuator, the black attenuator in the picture. And then we have a system computer interface. We're using the CubeSat space protocol that is standardized. It's run over the CAN bus. And then we do in-orbit firmware upgrade of all the software into the evolving VDES standard via RS422. That's common for ship also. And we also do in-orbit VDES radio frequency raw data recording. So we take some slots in raw data, and that could be later retrieved to the shore and analyzed repeatedly. And then we're also using Ethernet for configuration and monitoring of the payload. Here's a little small specification about the satellite transceiver. Again, the same picture of how big it is. You can see the form factor. The weight is roughly 500 gram. You can see the power consumption, and note that during transmission you have a little more power consumption. We're implementing, as Magnus also was saying, we are implementing the full spectrum of VDES here, according to 2092. You can see also that the power output here. It is an IOD, so we're gonna experiment transmitting from 1 to 6 watt, and that is configurable. This is my last picture here from this presentation. It's about a vision. You can see here that what we are saying is ship, shore, ship, sat, and sat ship communication. And if you're talking about terrestrial VDE, in an archipelago, for example, up to 30 kilometers from the stations, we're going to have roughly 300 kilobits per second. And the ASM part of VDES will be a little more distances, 100 kilometers, but slightly less communication capacity. And then we envision the satellite VDE on a high sea global coverage, each satellite 100 kilobits per second. Yes, thank you. Now I'm not representing Saab. In my next presentation, I'm representing what we call VDES Alliance. And I'm the co-chair of VDES Alliance, and the chairman is from Stanola, Stefan Pillmeyer. Next page, please. Sorry. I have 2 points on the agenda. Why should we have something like VDES Alliance? And when I explain that, I will show you how you can become a member of VDES Alliance. The technical progress of VDES, we have seen that this week is very fast. IALA, ETU, IAC, and also IMO is doing a lot of good work here. But something we lack is what I'm calling interoperability power between vendors. Non-interoperability with VDES units is a risk, and VDES Alliance can mitigate that with physical test campaigns. What I mean with physical test campaign is that engineers from different vendors are sitting in the same local and integrating units from different vendors. We are already testing that, and it was starting with a great success. And we are inviting, in principle, all the vendors from all the world to participate in this type of physical test campaigns. Marketing of VDES needs to be enhanced. And I think that IALA, ETU, IAC has not that VDES focus, but VDES Alliance can be that focal point and marketing VDES. And the global network of VDES stakeholders can stimulate the users of the technology. And is this our idea? Maybe not. Alliance type of non-profit organizations is common in advanced communication systems. You have Wi-Fi Alliance, you have called the PNT Alliance, you have something called VDES Alliance also. So there are these type of communications alliance for common technologies. And how to become a member here? Becoming a member is a natural step for your company or organization to bring VDES, both products and services, to the market. We have a homepage, you can see it here, and you can apply going to this homepage. And the cost for non-membership, for observer memberships, is €750 per year, and contributor membership is €1,500. I'll make a note there, observer memberships is designed for non-industrial observers, like maritime security organizations, government, and so on. And product companies like Saab and so on, JRC and so on, that will be for the contributor memberships. The contributor memberships get also votings in the VDES Alliance. That could be it's a way of also to make contributions on the way progress for VDES as well. And the contact information is here. You can see that the organization itself, we have it's co-located with Stanola. Yeah. Thank you very much.
Thank you, Peter. Next, we have a pioneer of the first ever VDES satellite, Hans Christian Haugli. He has more than 30 years experience in designing, deploying, and operating in raw data rate systems. He was involved in the launch of NORSAT-2 with the VDES Sat payload in 2017, he will have interesting things from extensive previous experiences. Hans, you have the floor, please.
Thank you. I will test out the cameraman here because I prefer to talk while I speak. So I see I'm still on the camera, so that's a good sign. If I could get my presentation, perhaps I push. There we are. Thank you. First of all, I'd like to thank the Ocean Pacific Research Institute for being invited here. I think the initiative is a very good initiative. And also I want to take the Japanese Coast Guard for arranging the VDES workshop. I think it's great that Japan gets on board and gets active, and we are pleased to join in and work with Japan on this very important issue, because we really believe that the solution for VDES, and especially the satellite part, is an international solution. I'm going to talk about the VDES sat experiments and testing we have been doing since 2017, when we launched the first VDES satellite. So we have more than 5 years experience with both testing operations, and we made a number of experiences and lessons learned, so I'll share some of those with you. There is not sufficient time to explain everything we have done, so I would encourage you to just look at the slides when you have time, and then get in touch with me later on if you want to talk about further cooperation. We have infrastructure in space. We have cooperated with many organizations around the world. So we invite you to get in touch with us if you want to keep on testing and do new things on VDES, and then we can share our experiences. First, I will start with the Norwegian perspective. And there are really 4 elements which are important in Norway when it comes to VDES. The first one is the Navi Area 19, which is quite a huge area, as you can see there between Norway and Greenland. Norway is responsible for that area in terms of search and rescue, etc., within our region. The second element is the natural resources in the region. There are very significant resources such as rare earth, fish, etc., in the region. So this is also very important for Norway. The third element is that we see our neighbor to the east, Russia, is building bases and new fleets in the Arctic. So obviously it's important for us to be aware of what is happening in the Arctic. And the last thing is the Northern Sea route, which will shorten the route from Japan and China to Europe by approximately 30%, because the ice is receding in the Arctic, so people could take the shorter route. This would also possibly affect Japan, and that will mean that traffic in the Arctic and along the Norwegian coast could increase significantly in the future. Now, there is a situation in Ukraine and other places, so we don't know exactly how active the Russian route would be. But we do expect that, for example, the Chinese, we're quite pleased to use that route to save on time and cost to get across. When I looked at this slide, and I came here to Japan, and I saw the slides from Japan Coast Guard, I was very interested to see that many of the issues here were very similar to Japan's issues. So the safety and rescue and those things I saw in Japan, and natural resources I saw in Japan. We saw a bit of what we call illegal fishing and other things there, which is an issue there. And of course, the Northern Sea route, I think, was also touched upon, which would affect Japan as well. So it seems that on what I call the macro level, we have some similarities in needs. So this is the macro. Now a little bit more to the micro level. So first of all, why is Norway? Why did we start VDES Sat so early? We started the activities here in 2015, and we launched the first satellite in 2017, 14th of July on the Soyuz rocket. And I share the excitement that I heard here from Stanola when you see the launch. We will not launch on a Russian rocket for a very, very long time, but nevertheless, to see these things up is very exciting. We had more than 18 million horsepower on that rocket in 2017, so it's quite an experience thing. The Arctic region, and I've shown here in these blue triangles, and the blue triangles here show a satellite traveling from the north to the south. That is the red dot. And as we travel from the north to the south, we turn the satellite body so that the coverage area will match where the satellite is and cover Navi Area 19, which you saw on the previous slide. And we think that's quite an old way of doing it, and we're very pleased in a way to see that the newer satellite carriers like Stanola and Saab and others are also using the same type of Yagi that we were wondering was the right thing in 2015 when they specified the satellite. Another reason for Norway is that it's a huge area, and if you want to do this with base station, we need several hundred base stations to cover this area. And that would be very costly. And secondly, there are not enough islands to place these on, so that would not be possible. So using satellite to cover these areas, we think is very, very cost effective. We have been active in Space Norway in IALA from 2015, and we spent a significant time and effort to write the satellite part of the VDE standard. And also, we realized that to get this frequency for VDES satellite approved, would not happen by itself. So we took quite active roles leading the IALA activities in ITU and other places, and also the leadership of CEPT for Europe. And we have a participant who basically led Europe at the large conference in 2019 when frequencies were allocated to VDES satellite. And if we hadn't managed to get VDES satellite frequencies allocated, we would have had no services. And I have to say that we have very significant opposition from the Russian administration. And that was a bit of a grind, but we persevered, and we had a lot of friends and support from all over the world. So we were very pleased when in the 2019 frequency were allocated from 2021. We have, as I said, tested many, many aspects of VDES from 2017. And in the beginning, we thought this was going to be very easy and happen quickly. What we have learned the hard way is that there are very, very many elements, and you have to make everything has to work before the whole chain works. So, you know, getting a satellite launched, that's step one. And beyond that, there is probably another 50 steps before, at least from our experience, you got a stable service. So we'll go to the next slide. So here I'm going to show the world's first VDES satellite. It's shown on the top left here. That's the NORSAT 2 satellite. It has this deployable Yagi, which 8 dB IO gain. To the right on the top, you see the Kongsberg CTEX VDES transceiver, which has been operational since 2017, and you know it's more than 5 years in operation and is working well. I've shown that the drawing in the middle there is really the coverage area, and if you look closely there, you will see that the satellite coverage is about 1,600 kilometers by 2,500 kilometers or 2,400 kilometers, which happens to match this nav area 19, which is what we wanted to cover. So it was not an accident. We ended up with this beam and this satellite because we matched it to the coverage. So I think here in Japan, you have to should decide what satellite area you want to cover and select the satellite antenna on that basis. And it's a way to calculate this. I'm not saying it's straightforward, but I'm sure you have good engineers who can do it. And we'll be happy to work with you and find out how to do it. Well, some of the key learnings. The first one was that most of the time you will see the satellite at very low elevations. Half the time the satellite is below 12 degrees elevation. So it means the satellite is between 0 and 12 degrees. 80 to 90% of the time it's below 30 degrees elevation. So the satellite is usually at very low over the horizon most of the time. There are very few passes who come overhead. The second thing we found was that the link budget, when you calculate the signal strength, is very close to the theoretical link budget. We found errors of around plus minus 1.5 dB for the whole chain, which we're quite happy with. But what we did find, which did surprise us a lot, we found very, very significant fading. We see signal fading where the signal fades more than 15 dB from time to time. And this is caused by what we call specular fading. So this is an important factor when we designed the system. And when we delivered, for example, the world's first ice chart together in an ESA activity, we put in what's called link layer coding to enable that you get that ice chart through the link in 2018. And that was on the 4th attempt when we got that one through working. The second thing we learned, apart from fading, is that the uplink interference is very, very significant on occasions, especially when we flew over what we call Russian territory. We saw that the Russian radars were about 1 million times stronger than over ship signals. So these were extremely strong signals, but we found ways to handle these very peak powers. And the last thing we saw was that we saw that even locally on the ship, when we had signals down from the satellite, that the interference would vary both over time and location. So what we found was that the performance would vary over time. And in general, I would say that we got packet error rates from uplink and downlink between 5 and 10%, even with high link margin systems in some waveforms. So it's quite important that you take this into account when you want to optimize your services. I'm going to talk about a couple of applications here. This can be more complicated, so if you don't understand it, please pardon me, but then read the things afterwards. The first service we looked at after ice charts, what we call search and rescue coordination. And I've shown here, if you look at the bottom to the left, you have a ship which is in distress. It gets a message to the Rescue Coordination Center in the middle. The Rescue Coordination Center transmits to individual ships in the region, shown on top, search patterns. And the ships will do the searches, and then the ships will report back the actual search patterns into the Rescue Coordination, and the Rescue Coordination then can see exactly where the search has taken place. This is the second most important service in Norwegian waters. So this was some activities they did with Norwegian Rescue Coordination Center and the Norwegian Coastal Administration. So this is an example of a service that we have tested, and we found it working. Another service we tested it relates to the maritime domain awareness. The issue here was that in the middle we see Norwegian Coast Guard Svalbard. It was heading for the North Pole in 2019. However, it was a very light icebreaker. It could not handle much ice. So what they wanted to know is how thick is the ice through the Arctic to the North Pole. So what we did was that we collected AIS position report from a lot of satellites. We looked at all satellites north of 75 degrees, and we reported it back to this vessel. This vessel identified a Russian icebreaker going up to the North Pole at 18 knots through the ice, and basically followed the track of that icebreaker and came down. So it went from Svalbard to the North Pole and back in about 1 week, which we think is a record time. So we thought that was interesting. The Russians didn't like it, so they declared the area a missile test area, but that was too late. Another area we have seen is we observe that GPS gets jammed from time to time in our regions. So we are testing on our new satellite. We will be launched in April this year. We are going to test basically VDES satellite R mode, but we are doing that using the standard VDES signals. We've done some tweaks to it, but the signal follows the ITU recommendation. No changes to that. With that, we can basically determine a ship location independent of GPS, or in connection with, for example, R mode on land, or we can even use it to verify that the GPS position on the ship is not spoofed. So we'll test that out, see how good it's going to be. We don't expect it to be anywhere near as good as GPS, but we think it will be good enough for some applications. Here is a difficult chart, so I'll try to explain it to you. If we start to the left in yellow, we are shown a ship terminal, and basically we divided the ship terminal into two types of applications. The top right one is the PC applications, which we have implemented. That's why it's shown in yellow. And then to the left, we have what we call the bridge application, which we think is further out. Nobody wants to hook up the bridge quickly. And we are using the Kongsberg CTEX VDES transceiver 300 for all this. In the future, it will be IoT on the ship. To the left, you see the different services, whether it's the coastal administration or some sources of different data. So, for example, at the bottom there in the yellow color, you see the search and rescue application. Next up, you will see the ice chart, where you can get the official ice chart, etc., etc. Higher up in the middle there, we are shown in white what we call a VDES REST API. So this is a place where third parties can connect over service and get VDES services. So this is, if you have a new application and want to work with us, this is the interface you would use if you could not use some of the existing ones. In the middle, and all these boxes, these are these boxes needed to run a VDES satellite system. In red there, you see the satellite control. Then we have a VDES router, which handles the conversions of data into the VDES format. And then we put a number of applications in there to get up and going, to get the services going. To the right, in green, there's another box we had to add in there, and that is a quality monitor, because we did find it's very difficult to find out exactly why the system didn't give the performance expected. So we were putting in quality monitors in 3 locations in Norway. So I'm going to conclude here. We have spent more than 5 years testing VDES satellite and develop infrastructure together with Kongsberg CTEX. And we have worked together very closely to make sure that all the elements work. And I do not know the number of software revisions we had, but just on the satellite, I think we had 11 software revisions within more than a month, the first month. So it takes time to get these things stable. I hope the other colleagues here to the right, we were lucky and get it right first time, but I wish you good luck. We are going to launch an additional VDES satellite this year, in April this year, on SpaceX. And there's a third Norwegian VDES satellites that the overboard approved for launch in 2025. So by that, we will have 3 VDES satellites. And we'll hope that the old one, which was launched in 2017, will keep on going. we think the maritime cloud is very promising, but we think some elements are missing, so we are not waiting for that cloud to come. So we will basically test and run services before the cloud is in place, but if the cloud is better, we migrate across. We think that a good start here is to start with safety services. And we are looking at Space Norway to strengthen the partnership with all international operators. And please get in touch with me afterwards or by email, and the contacts are given here, just below here, if you want to do something interesting and useful with it. So with that, thank you very much for your time.
Thank you very much, Hans. And next, we have a speaker from the leading aerospace companies in Japan. Akira Shisa, IHI. We have interesting thing from extensive. I'm sorry. You okay? And just a second. And also he talks about the Japan Satellite VDES Consortium as well. Akira, I give you the floor, please.
Hello, good evening or good morning or good night. Before I get started, thank you for participating in our workshop. And also, I would like to express gratitude to Sasakawa Peace Foundation for providing this kind of opportunity during this busy week. And so, again, my name is Akira Shisa from IHI Corporation. I working for Space Development Division as a head of a business development group. And first of all, I explain why IHI joined this consortium. And next, I'd like to explain the summary of the VDES Satellite VDES Consortium in Japan. First of all, here is the general information about IHI. We were started company since 1853 as a shipbuilding company. Now we have almost 30,000 employees, and we have 4 main business sectors, which are energy, environment, and industrial system, and social infrastructure. And my division is aero engine and space and defense. And our division, Space Development Division, we provide a lot of infrastructure such as rocket and satellite component of satellite, and also a lot of space utilization system in orbit. So from now on, we can launch a satellite, we can make a satellite rocket, but we did not start the data solution business. So we started to the satellite data solution business for a few years ago. So I'd like to introduce the summary of our space relations business, and we try to make a business, the 4 areas. One is the space station awareness, and the next is the marine domain awareness, and the third one is the Earth observation, and the fourth one is the long-term weather forecast. So today I'd like to explain our marine trial to the marine domain awareness area. We started the data provider of the AIS data in Japan. We are provider of the exact Earth AIS data. We started provide the satellite data and also provides terrestrial AIS data. We install around the Japanese shore. So, and next we started the analysis service for these data. For example, we are working on the forecasting arrival at the port through machine learning or historical data, or providing a maintenance service schedule based on our operating time calculated by the AS data. So such kind of service we started. And during providing the service, we have a lot of, we find out a lot of issue. One is we cannot find out the AS data in the conjunction area, so we'd like to start its research to how to get these data. So finally, we developed a new AS receiver to identify these AS data in the conjunction area. And so perhaps 2 years last year, we developed a 3U satellite, installed such kind of new AS receiver, and conducting the in-orbit demonstration in order to understand the capability of our developed receiver, and also to identify the issue in the satellite operation for the maritime monitoring. So we met the VDES communication next generation AIS. So we'd like to join, and we'd like to something about VDES new next generation AIS VDES. So next page. VDES has already been explained in various ways, so I will not explain detail, but I ensure the 3 points. One is someone says AIS 2.0, next generation AIS, so it including the AIS function, and we must do more useful using a VDES mechanics to AIS function, and more than higher data rate and two-way communication. So VDES communication via satellite explains the improved maritime safety and security from more than now. So next one is a Satellite VDES Consortium launch. Dr. Akmas explains the history of the consortiums. I'd like to explain briefly the member of the and opportunity. The IHI and other 6 companies, Moltec Trade and Furuno Electrics and XBS and TS Corporation by Nishimura-san, and JRC, Japan Radio Corporation, Mitsui Corporation, and also Ocean Policy Research Institute. We started VDES Consortium last October. And this consortium aimed to create a platform to facilitate commercialization and promotion of satellite VDES. And through the partnership between the industry, academia, and the government, and also include the other countries. So these are our objective. So what is our consumption activity? In order to implement the new standard of VDES in society, I believe that the rules and the business and technology must be established at the same time. So rule, business, technology must be same time. For the rule, we will form alliance with the government and the institution, as well as other countries, to create an industry standard. So we'd like to connect and discuss not only the nations, the organization, but also other countries. And also, in addition, technology area, we will achieve the proposed use case and research content. To the in Japan, government policy started to develop the VDES satellite system constellation development. So our consortiums connect with these activities and propose research or use case to include this good thing to this development. And for the business area, we will propose a business model that allows the VDES is a sustainability infrastructure. So we promote the alliance or for the future, the joint venture or something. So, but the space infrastructure is needed a lot of fee. So we need the business and we develop the business to continue. So to the end, we would like to consortium to be a platform for the space industry, technology industry, shipping industry, fishery industry, and other related industries to gather their opinion to discuss in the consortium and we propose these for the rule making, business, and technology development. Currently, companies in the consortium, these 7 companies, and so. But we intended to continue to accepting the members from the related industry to make a proposal. Last one is just propose to discuss the item. We a lot of discussing the consortium rule making or something. So this is a sample of our discussing item. One is a technical item is current AIS system, AIS location spooling or disconnects AIS signal. So using a VDES function, we would like to realize a spooling computation function or layering and encryption function or mechanisms to alert or things to prevent these problems. And for the rule making, current AIS is installed just only the big ships. So there is a lot of problem because we cannot communicate with the big ship to the small like a shipboat or something. So our goal is all ship installs the VDES and all ship can communicate each other. So for this issue, we discuss the incentive or license or law to promote or something. So we'd like to discuss these things. And the last one is the business model. Business, I explained the public use and private use business is balancing is needed. So for public use, how to get a fee from the public use, and also private use, we get a lot of money. So we'd like to provide the killer content on the VDES for business success. So these kind of issue we'd like to discuss in the consortium, and so let's collaborate and realize safe, most cost-effective journeys. We'd like to discuss each other, not only in Japan, but also these kind of members. Thank you very much.
Well, thank you very much, Akira. We are a little bit behind, so I move on right away. Next, We have a speaker from very unique satellite manufacturer, specialized for nano satellite in Japan. Takayoshi Fukuyo of Arcade Space. Takayoshi, I give you the floor, please.
Thank you. Thank you very much for kind introduction. And my name is Fukuyo from CEO of Arcade Space. Our company is very, very young startups. Sorry, we also the member of the Satellite VDES Consortium, and our company established in the 2018, 4 years ago. So we are very, very young companies, spin off from the University of Tokyo, and we are not just making the satellite for the maritime issues. Our company is focusing on the cube and micro nano satellites, mainly CubeSats, and this is here in our University of Tokyo's satellite, like a world first CubeSat in 2003, and also the microsatellite for the Earth observation. And we also participating in this operation of the lunar exploration satellite, like Equuleus, and also the Sony's satellites in the University of Tokyo and the JAX and Sony's satellites. We are participating in these satellite operations. And our company is satellite companies from the University of Tokyo, but our idea is making this satellite not just for the laboratory levels, for the new mass production systems of satellites. And for these VDES challenges and activities, for us, we are very, very newcomers, and but we found and we studied and learned by pioneers like Space Norway and the Sternur's activities. So, but we also found that this VDES and our CubeSat, like a 6U and 12 satellite, 12U satellite, is very, very good for these new VDES satellites. And we believe that these new CubeSat systems can contribute for this cost-effective deployment, building the satellite constellation for the VDES. So we are starting we just have begun these activities of VDES satellite development also. And our company have started with a 3U and 6U satellite, and we have started with this satellite for the IoT, low power and wide areas, networks, satellite communications, and also for the 6U Earth observation satellites. So with these our activities, we are now started this standard bus systems to meet various demonstration and business needs. So one of them is we focusing on the VDES antenna and VDES satellites. We are now developing these satellites, and about these satellites, more than 10, about 10 satellites for next 2 years we launch and operate, and one of them is our VDES satellite. Now we are planning to deploy this satellite in the early next year, as the fiscal year of the 2023 in Japan, Japanese fiscal years. And our idea, we have started this IoT satellite and the Earth observation satellite, and we also not just making satellites, developing this IoT data collection services. So we are now very happy to be the member of the Satellite VDES Consortium of Japan, and this experience of the IoT communication satellite program, we are now starting this AIS and VDES satellite development. But I will skip this VDES idea already explained by Shisa-san and Dr. Kamatsu, the OPRI. And so our activity for this satellite constellation, and I will not explain go in detail about this VDES satellite, but for us, just began studying this new satellite constellation. But I believe that this satellite constellation of VDES is just one country or just us. It is very, very difficult. So we very happy to learn from these European challenges, and also our target. We are starting with deploy this satellite starting in the low inclination orbit for the covering the Japanese interest area, like Asian and the Pacific Oceans areas. So I believe that we can cooperate and contribute to this satellite constellation VDES. And we also we would like to contribute as a member of the Satellite VDES Consortium for these activities. And our satellite, as I explained, that we will launch in next year. But after that, we are now discussing with the Satellite VDES Consortium, our members, and also IHI and the Japanese government. Our idea is until 2027, about 10 VDES satellites, and after that, our idea more than our target is 30 or 40 VDES satellites, and this in a decade. And but anyway, we would like to cooperate with this VDES Alliance or the other members for this more maritime safety and new challenges for the VDES and this satellite utilization. And we also we are the member of this Satellite VDES Consortium, and also we are building the new ground station in Shizuoka in Japan. Also, we believe that this cooperate this program with this our ground station network also, and we also discussing with the other Asian countries which has interest and starting the activities, the VDES or maritime issues like IUU, illegal and unreported irregular vessels management and monitoring. So we would like to cooperate through this satellite constellation building. Yeah, and yes, we distributing our handout about the other satellite informations. But we, as I mentioned, with IoT satellite constellation, and we also as Mr. Shisa explained about challenging using the satellite VDES, for our challenges is for the spoofing prevention functions and the encryption functions. This is for the maritime issues very, very important. So with our partners in Japan, we now starting these studies and using the other satellites also. Yeah, and thank you very much. Yeah, so.
Thank you very much, Takahashi. So I now take your questions. Yeah, I got one question from the audience, from online. This person's question is, the speakers said abroad, yeah, for Japanese perspective, development, satellite VDES, AIS 2.0, these development, research development, the fund and human resources, the fund come from government side. But what kind of fund, or from government side, or you are satisfied or not? But maybe Space Norway, or you probably have experience in the funding from the government or European Space Agency or something like that. Hans, please.
Thank you. Yes, I would say a lot of our VDES activities were financed by the European Space Agency, and Dr. Nada Laga here among the audience has been an important driver for VDES, both in the standardization work and others. So that was quite essential for us to take the risk in the beginning, where we launched the satellite before the standard was approved. which is a high risk. So anyway, so without the ESA funding and Norwegian Space Agency funding, we would not have started this activity 5 years ago.
Yeah, and for the VDES Consortium, it was the Swedish Transport Agency government funding that was supporting us with roughly 70% of the money. And then Saab, OSEA, Clyde Space, and Orbcom equal share 10% each to launch the first IOD satellites. So thanks to Swedish authority money, taxpayers' money, you say.
You pay.
And for Sternula, it has to a large extent been funded by the Danish Innovation Fund, but also by private investors. So it's around the same amount, 70% from public money and then the rest from private investors.
Thank you very much. Any questions from the floor? Please.
Thank you very much. My name is Miyama. I'm from the Japanese Committee for the Space Usage for the Security, Defense and Security, non-profit organizations. I would like to ask Mr. Hans Christian. In your presentation, I found a very important example for the usage of the VDES. And as far as my understanding is correct, you mentioned that the Coast Guard ship of the Norway, Coast Guard ship of the Norway was instructed by the VDES system, and as far as follow the Russian vessels, and consequently the Norway ship could went through the right way, and I understand that they carried out the missions. And did it mean that the Russian offshore vessels are one of the customers of your VDES systems? Is it right?
Thank you. No, all ships under the Polar Code in the Arctic need to carry an AIS transponder, so the Russian vessel was basically transmitting its position. We had 30 or 40 ships in the region at the time, and Norwegian Coast Guard vessel looked at all ships around the polar cap and looked at the speed they had through the ice and said that would be a good indication of the thickness of the ice. So they selected a route which happened to show that was a rapid route. This vessel, so that's basically every vessel transmitted position. We had the MMSI, so we knew which vessel it was, and you could make a judgment whether it would be a good route to follow. We did a second test with the Norwegian Coast Guard. This was a year later when they went all the way from Svalbard to the Bering Strait and back to pick up some buoys. At that time, there was not any Russian vessels to follow, but they used it to understand if there are any vessels nearby, like icebreakers. So if there are icebreakers nearby, they would be a bit more aggressive than if they were 14 days from an icebreaker. So they basically used that information about all the vessel to decide on the strategy, how thick the ice they wanted to engage. And if the ice was too thick, then they had to kind of go back and find thinner ice. But basically, by knowing who's around you, you can make perhaps better decision and lower the risk as to what is the fastest route versus the risk.
Thank you very much.
Omar, please.
Thank you very much. My name is Omar Fritz Eriksson. I come from IALA. I work with the IALA Worldwide Academy. But previously, I worked with the Danish Maritime Authority and for about 30 years. And this maritime connectivity platform, the concept of that was actually born on my whiteboard in my office many years ago now. But Hans Christian, I'm sorry, the other speakers, but everything is centered around Hans Christian. You mentioned the maritime connectivity platform and that you were looking into it, but it was missing some elements. And I wonder what element is missing, because we think it's perfect.
Thank you. Yes, your own child is often perfect. We haven't gone too much into detail, but for example, this ice chart distribution, we needed access to the Norwegian Met Office service to get the ice chart. It needed to be a special format. We needed the files to be certain sites. We were not aware that this would be available on this platform. Platform. So I think it will be there in the future, but it's a bit of chicken and egg. My impression is that, if somebody has a need, the service will be developed. But what we find is that so often you have to demonstrate the service first before people understand their need. So that's what I'm saying, is that I think it will go that way in the future, perhaps, but it's also a question whether or not we want to connect to the bridge, an open internet platform or not, and that's some questions that I'm not to decide. So we were having some concerns in that regard. So we thought we give the coastal administration the options that we can make applications that they have full control over, that we've done with Norwegian Coastal Administration, or if in the future they want to connect into a maritime communication platform, that's fine too. But we thought it was important that the coastal administration has full control of the data flow to ensure that have proper integrity of the data, that they don't get false data.
Thank you very much.
I got a question from one of the audiences online. What about the future of AOS satellite roadmap? Magnus or Peter?
Yeah, maybe I can answer about AOS. We have our own homepage, and our vision is to create a global communication system with VDES. But as I pointed out, we get finance for just one satellite now. We are planning for more satellites, of course, but we will send up our first satellite first and adapt to that. So just one satellite now. It is an IOD satellite, it's an experimental satellite. Just now, we are not aiming just now for selling the data, but keep in mind that Orbcom is today operating 14 or 15 AIS satellites. So you can buy from them a feed for a global coverage of AIS, 110,000 AIS targets. And of course, the planning is for a constellation, but no decision yet. Thank you.
It was a little bit of an answer or following up on the question by Omar Fredriksen about the maritime cloud or the maritime connectivity platform, because in Stanula we believe that the maritime connectivity platform has matured now to be the foundation for the digital services that we want to make available out there. And in our collaboration with the Danish Meteorological Institute, which is our key use case that we are going to demonstrate now this year for a weather service and an ice service, we are going to make use of the maritime connectivity platform, especially the NaviLink setup, which is is hosting a maritime cloud, you can say. And we have also had developed this MMS Edge router, which is what you need on board the ship to act as this MMS Edge router that you want as the representation on board the ship, so the ship part of the maritime connectivity platform. So a lot of standardization has happened over the last 2-3 years, and it's also the main topic of what Alexander is going to talk about later, so I'll not go into more detail about it. But it is something that is very important for the orchestration of the digital services, because we have to see VDES not on its own, but as something that will coexist and work together with other connectivity options. In some cases, it will be an advantage to use a local mobile network if that's available. It will be an advantage to work with other satellite networks in some cases, for some use cases.
Please, Awai-san.
Yes, thank you. It's about the VDES Alliance. As we have the VDES Consortium in Japan, my understanding is that the VDES Alliance is primarily intending to coordinate the commercial aspect of VDES to make up a nice business model. But besides, you have the government observers like the Coast Guard. So can you show us the typical example of what requirement is presented from the government and how the VDES Alliance is going to reflect such requirements in the future VDES configuration?
Peter.
Maybe I don't understand your question, but what we are primarily doing in VDES Alliance is we need to mitigate interoperability. When we designed AIS more than 20 years ago, everybody goes to BSH or similar organization, and that was sufficient. You're testing one vendor equipment against one test equipment. That was sufficient. But today with VDES, it's a more complex system. So of course we're going to use BSH and similar organization for testing for compliance. But we think that is not enough. We need to have some interoperability tests between different vendors. For example, now Japan Radio Company has been a member of VDES Alliance. Mr. Nishimura himself is sitting in VDES Alliance board. And we try to have all the vendors of VDES base stations, ship-on units, and also satellite providers. So we have one system, not dialects of VDES, just one system. Of course, we can compete on the market, but it should be the same system. Did I answer your question?
Yes, thank you very much. Well, I may not be fully capturing the objective of the VDES Alliance, but as I see from your slide, the government sector is also represented in the VDES Alliance as observers. So what the role is expected of the government observers in the VDES Alliance?
Okay.
Is
what we're saying is that if you're like a Coast Guard, you may have some applications you want to address that we now. VDES is more a communication. So AIS has their own applications, but VDES is more a pure communication link. You may have some applications as authorities that we may not have think of. And you're more than welcome to join VDES Alliance and take up these topics. And we will, of course, address it. Yeah, thank you.
So thank you very much. I'm not going to take too much time, but my question was because the VDES is intended to implement the commercial services as well as the public services. So that's why we are here. The Coast Guard is committed to the VDES Consortium in Japan as an observer. So that is the primary intention of my question. Thank you very much.
Any questions?
Good afternoon. I am Raju from Indian Institute of Technology. My question is to the panel. Will there be any benefit for fishing vessels and small crafts by VDES, implementing VDES? Thank you.
I think Ras.
Yes. Yeah, I'm talking. To a large extent, VDES is meant for not for the high-end big container vessels, because they can afford a quite expensive satellite link, no matter what the cost almost. But the VDES is special by being carried to the ship over a VHF antenna. So the services that will be available will also probably be very much of interest to the fishermen, and that is like the public services, weather services for Danish Arctic waters, the ice warnings that we are going to test soon. So it's a technology that is actually meant for not just the big guys, but also for the fishermen. And that's also where we expect a lot of the growth in terminals out on the ships will be.
The second one is on what type of investment these crafts need to do. Will be the existing device helps, or we need to upgrade it?
The VHF antenna is there and can be reused. But of course you need, just like when you want to use a 5G, you have to have a 5G phone. And then we have the vendors like Saab and JRC for Ono. So it's just a matter of, in the beginning, I guess it will be mostly the high-end products that supports VDES, but in the long run, in 2028, there will be low-end products, and there will probably also be IoT solutions, which are extremely low cost, but for different use cases. But it is supposed to go in the direction of low cost.
Thank you.
Well, I have one question, but the path we are on is not a rosy future. Rose means flower. It's a happy future. But difficulties lie ahead, of course. Everyone knows. Here we have some of the best in this field, and I'd like to ask a question that is a headache. But I hope they will solve the problem smartly. Well, if you take a look at the World Radio Communication Conference 2019, WAC 19, and final acts, here are some worry statements. The use of the frequency bands, the Maritime mobile satellite service, which means a space to Earth downlink, is subject to an agreement obtained with respect to the terrestrial services in Azerbaijan, Belarus, China, North Korea, Cuba, the Russian Federation, the Syrian and South Korea, and South Africa, and Vietnam. Would you negotiate with the radio authorities of these governments if you transmit the downlink? Or, otherwise, what do VDES satellite do in the sky over these countries? Hans, please.
We have filed for applications, and of course we have sent the documents to Russia and other nations, and Russia has asked for what we do, and because we have the Yagi antenna, we will point the antenna in such a way that we not transmit over Russian territory. So that's the benefit having a Yagi, that we can actually rotate it to control the coverage area. We don't think from a practical point of view, because VDES is a kind of secondary license, and in any event, they will need to prove that it's causing interference. And we think it's very, very difficult for a downlink VDES signal, which has a typical signal level of minus 118 dBm at antenna port, to be interfered with another signal, because the satellite is 500-600 kilometers away at least, if not 2,000 kilometers away, and has we transmit with 0.2 watts of power, while then you have a base station or terrestrial station would transmit perhaps 25 watts, which is much closer. So we do not think this is going to be a practical problem. Yes, it could be in harbors where we have ships nearby, but it's not that satellite will interfere too much with terrestrial.
Ras, what about your...
Yeah, of course, we have had to consider this as well. And I'm not so concerned because we are able to predict pretty much how much interference we cause on the ground. And then it's just a matter of pointing the antenna in the direction of where our customers are and potentially turn off the transmission when we are in a place where we are not allowed to transmit. We can tilt the antenna up and down also to optimize the use of the radio. So yeah, we feel that we are in control, and for the countries where we don't get the permission to transmit, that's going to be the solution.
Thank you very much. Time is up. I'm a bit worried about there's some questions on the floor. Please.
Well, thank you very much for the opportunity. I would like to thank also the organizers of this interesting forum. My name is Nader Alaga from the European Space Agency. One question I had for colleagues from Japan, part of the consortium. This timeline was mentioned regarding the development of 10 satellites in the next few years. Is this mainly on the satellite domain, or do you have plans both for the terrestrial and satellite? And a bit of a timeline on how this is going to be funded and how the activity is going to start, if you have any chance to talk about it.
Thank you for the question. Just a planning, but our plan is not only the satellite, but also the terrestrial area, and all the system need to be developed. So currently, schedule we join and we provide the same terrestrial area, but that is just technical development, so service after that. So currently we plan to 2027. Until 2027, we developed these kind of techniques, and after that we can start it. But we have a chance. If we have a chance, we try to start the business. But the end is 2027.
Okay, everyone. You probably have any questions, but the organizer will receive questions by email or maybe. And I'd like to wrap up the session 1. Thank you very much for.
Thank you very much, Mr. Nishimura and distinguished presenters. Now we are, before going into the session 2, we are going to have a short break. Now it's almost on in time, so we are going to have it by 4:40. We have around 10 minutes break. Meanwhile, for presenters in the session 2, please get on the stage before the end of the break. So see you very soon later. Dear participant, we will resume our forum in 2 minutes, so please have a seat and please be prepared for the next session. Thank you very much for your punctuality. Now we are going to resume our forum. From now on, we are going to go into the session 2 of the panel discussion. It is of the discussion topic is diverse. It's about operation, business model, and training. And I would like to ask Ms. Gillian Carson-Jackson to facilitate this session 2. So Gillian, please take the floor.
Thank you so much, and it is certainly an honor to be here at the OPRI and with the Sasakawa Peace Foundation once again. I would like to thank the very strong support we've had over the years, with a special thank you to my very good friend who's sneaking around the corner there, Mr. Kudo-san, for his support in the development of digital communications as a whole, and specifically with the work on VDES. We have expert speakers here today to address a very interesting topic, as was highlighted, this sort of the business case, the training, the societal expectations for what we will be doing with communications. Now, it looks like there's very few of us here. We do have another speaker who will be joining us online, live from London. What I will be doing right now, though, is just a brief introduction of each of the speakers, and then I myself would do a very short presentation, and then we will pass through the speakers as you have them in your program. So I will be your first speaker. My name is Gillian Carson-Jackson, and I have been involved in the maritime industry this year. In 1983, I joined the Canadian Coast Guard. So in 2023, this is my 40th year in the industry, which is very exciting. And I am very pleased to be here once again to talk about digital communication and VDES. We will also hear from Mr. Yoshihiro Sano. Yoshi has graduated from the Mercantile Marine in 1988. So we are very close in time joining the industry. He had a career as a radar engineer and has passed through many different careers with so much expertise that he'll be able to share with us. We will then hear from Professor Dr. Axel Hahn, who is a good colleague of mine for many years now, and he is the director of the DLR Institute of System Engineer and Future Mobility, which was founded in June of 2020. But he has many years of experience in this industry, and I know that we will have a very interesting presentation from Axel. And then joining us from online, from London, where he is at the IMO right now, is the Dr. Koichi Ushida. Koichi-san is the visiting professor of Kobe University at Yokohama National University. He's been working with IMO GMDSS for many years, and he will have a very unique aspect to present to us. And I have been told that he will magically appear on screen at the correct time. So I'm looking forward to that. I'm very pleased to be here, and now I would like to move into my own presentation. And I'm a bit like Hans Christian, I don't sit very well to present, I must stand. So I am here to talk to you a little bit about the evolution of digital maritime communications. And I'm going to start a little bit at the very beginning. And we had this idea already. In the beginning, in communications, we had many different ways to communicate, but it was always very, I would say, analog. Anyone here remember semaphore or Morse code? I got a couple of hands up, that's very good. So we had ways to communicate, but it was often very difficult to communicate over distance. However, we did have language-independent communications with the use of flags and the use of symbols, so we were able to communicate. Then we had this information explosion, and I think we're coming to the end of the information explosion, where we started having so many different types of digital communication opportunities. The introduction of digital communications, IoT, this has really revolutionized the way that we communicate. It has been truly this concept of disruptive technologies. Now, disruptive technology does not mean a negative connotation. It means a change, a concept of change. So we are coming into an era of information management. Now, information management means that we have data sources coming at us from many different areas. Those data sources are now being collated and presented in usable format. And information can be shared more collegiately, can be shared more effectively amongst the users, the fishers, the ports, search and rescue, administration. But in order to do this, we need to meet societal expectations with, yes, we have technology, but we need policy. We have the need for systems that interact within a governance structure. And we need to have that vision, that strategy. So we have these pillars that hold up this concept of a coordinated communications network. And you can see in there we've got drones, we've got autonomous ships, we have data available as required, when required, this idea of that single window. So we can have data shared. And it is because how we communicate, how we live, how we work is always evolving. We have Industry 1.0, we have Industry 2.0, 3.0, and we're all familiar with Industry 4.0. So this is where we're at with cyber systems, Internet of Things, the concept of networks. We are now moving into Industry 5.0. The human-machine integration, this idea of cyber-physical cognitive systems working with technology. So how we work is evolving, how we communicate is evolving, and how we organize that communication. And I'm going to go a little bit back in time. We've already heard about some of the excellent work about moving from AIS to VDES. So I always said that AIS is a bit like your country road. It's got 2 lanes. You can get a bit of traffic through it. The very basics, what you need in order to do your job, you can get that through that little road. But we want to do more. We have more that we need to share. And out of that desire to do more, just like your country road becomes too small when you get more buildings, more cities growing up, you need a wider road. You need a bigger road. You need something like, maybe VDES is not necessarily a super highway, but it does provide the ability for more information. There's more lanes, there's more data packets that can go. Those cars, if you think of a car as being a data packet. And that is that move from AIS to next generation AIS. And we heard about 2012. And I wanted to put this picture up because it was on the 3rd to the 7th of December of 2012 that we made the change from the next generation AIS to VDES. And you may see some familiar faces in that picture. You may not recognize that one, but that is me. In 2012, that was me. So we have gone through this concept of evolution of communications, the move from our country road, the building of the infrastructure, the city that meant that we had to go to VDES, more communication, more data to be shared. And we have come up with this concept of the next generation of AIS or VDES. I would like to talk about the fact that we need to communicate in the industry. I'll try not to move too much. We'll communicate in the industry across a very large area. Maritime is vast. In the IMO, they have identified specific types of navigation where you go. So if we think about communication in ports and approaches, how do we communicate? What are the options? Well, they're growing. VDES, 4G, 5G, Wi-Fi. So within the ports and approaches, we have multiple means of communication. I can pick up my phone, and I can say, I'm on 4G now. I might be on 5G later. Maybe one day on my phone, I'll say I'm on VDES, although the technical people tell me I won't be able to do that just yet. But it's a communications. It's just a way to get the data through. How I do it is not really all that important. The fact is I can. Then we go further out. Coastal waters, confined waters, areas where there's offshore infrastructure. There's a need for communication here as well. And the types of communication, again, we change, but we have multiple ways to communicate. VDES, VHF, perhaps in future, VHF digital voice. Again, VDES, MFHF, digital, satellite communications. We go further offshore, open sea, the polar regions. We heard of the polar regions and the need to communicate. I love that image of following the icebreaker. I spent many years on icebreakers in the Canadian Arctic. I've been to the magnetic North Pole, not to the geographic North Pole, but the magnetic, past the magnetic North Pole, many times following we're the icebreaker with like a mother duck with little ducklings behind us. But you need to communicate. In the open ocean, in the polar areas, other remote areas, again, VDES with the satellite, HF, digital. We have opportunities for multiple ways of communication. This leads me to the concept of trust. If I'm going to communicate with my colleagues, if I'm going to use my phone to communicate, I need to have trust that if I dial a number, it's going to the right place. If I make a broadcast, it's going to be heard. We need to have trust. And I think for trust, we need 3 key areas. Effective regulations, robust technologies, and values and ethics. We heard of those a bit earlier. If we have effective regulations and good technology without values and ethics, we end up with an unethical situation. If we have robust technology with values and ethics, but we don't have the regulations, and this is sort of when technology takes over, we may end up in an unlawful situation, using spectrum or using opportunity that is not actually within the legal area. And if we don't address that robust technology, we're going to end up with a fragile aspect. In the middle is your trusted system. And we have some key points about what is required for those trusted systems. So that legal structure, the fact that we need that technology to to be predictable and to be stable. And we need to ensure that we address values and ethics, but whose values and ethics? What are the sensors looking at? What are they processing? So just to start our discussion, I wanted to highlight a little bit where we were, how things are changing, and how we might move to an area of trust. So thank you very much. Okay, I'll take off my presenting hat now, and I'll put on my moderating hat. And it is my pleasure now to pass over to my colleague, and after many times now online meeting to talk, Yoshi Sano, please tell us a bit more about your case for VDES. I think if you just pick it up and talk, it should work. I hope.
Thank you. Thank you for the kind introduction and a wonderful presentation. I'm very surprising. I'm following your presentation. I'm doing the presentation, yeah. And thank you for the excellent opportunity to discuss with top runners of the Satellite VDES worldwide. I am Yoshihiro Sano from MOL Technotrade. My parent company, the same as MOL, that almost people are pronounced mole, but a mole is seem to similar to the animal, and they're digging the ground. So my boss don't say the mole, but MOL. But I like mole. Yeah. And it's meaningful that I participate here from the shipping industry because ship owners wonder if they need another satellite communications. So I will consider some use cases to discuss future maritime business platforms. Satellite VDES will be the equivalent of an IoT network in a smart city. Later, we will compare throwback anytime, anywhere on the network and universal broadband. Ship crews want to chat with their lovers daily and enjoy the video streams. In addition, fleet manager wish to monitor their ships every hour. However, they wish ships to connect with the land anytime as well. Let's clarify the proper use of both communication lines. In that case, we'll clearly see the following business models in the sea. The Satellite VDES Consortium in Japan is talking about comparing use cases. I will lay out the use cases by splitting some areas. The first is a contribution to the profit of ship owners. The second is the safe navigation. And next is a convenience for ship officers to rule compliance. Also, the environment is one of the most expected topics. At last, I want to consider gathering data from the sea. Even with cutting-edge technologies, ship owners will only pay cost for profit. So the system needs to earn more profit or reduce cost for spreading. For instance, what do you think about a total navigation control from the departure port to the arrival places, like an aircraft? We can already use the weather routing and comprehensive navigation planning. Suppose every vessel can depart and arrive at the port most efficiently. In that case, we can save energy cost meaningfully. It will reduce greenhouse gas as well. The next is cargo monitoring. It's a good service for customers. They might agree to raise a freight rate. And a vessel monitoring capability can decrease insurance rates. People say VDES can change the collision avoidance revolutionary. Data link has potentially beyond our imaginations. Ships, even crewless vessels, can communicate between machine and machine. And directly, an AI-controlled ship can maneuver automatically, avoiding collision with multiple other vessels. It's the most exciting capability of VDES. And recently, GPS and GNSS jamming spoofing threats commercial vessels. In that case, measure navigational equipment alarms at once and reduces the functionalities. In a pinch, Satellite VDES would appreciate it if the system would provide position, navigation, and timing signal to the vital equipment. Surprisingly, there must be direct communication between cargo vessel and the fishing boat. It's beneficial if we can communicate easily with each other to avoid the collisions. The ship crew is busy, especially when approaching a port. The ship officer must check that the documents and the duty equipment work correctly. Suppose VDES shares the data relative to conformance of the rule automatically, enough earlier than berthing. In that case, the burden of the crew will be significantly reduced. When almost peaceful voyagers utilizing vessels, VDES, we can notice ships that conceal or deceive themselves. Therefore, reporting the authorities near suspicious boats will contribute to keeping the sea lane peaceful. Suppose receives an update with the latest status of the regulations timely. In that case, we can avoid trouble with a local government. So nowadays, controlling greenhouse gas emission is a top priority issue for the shipping industries. Installing satellite VDES on any vessel will contribute to recording and sharing environmental impact gases. When a vessel spills hazardous substances due to distress, Satellite VDES shares data immediately and prevent further damages. Regarding the first topics, ships must slow down their speed to reduce GHG emissions. Slowdown operation is good for the Earth, but impact any stakeholders of maritime logistics. We must utilize data to maximize the operational efficiency under strict regulations. And I love the dream of ships gathering valuable data from the sea as same as transporting the cargo. Scientists, writers, nomad workers and unexpected people might live on the vessel together with ship operators. Extending human survival to the sea is a fun thing to do. I have spoken about what I expected from Satellite VDES. By the way, can we realize the fantasies without Satellite VDES? Several maritime broadband communications are available, and the big, well-funded shipping companies are eager to subscribe to high-speed services and advance the digital transformation for their fleet. When Satellite VDES becomes available in the next few years, the shipping firms will have already spent considerable money on the other services. Can Satellite VDES and broadband services coexist? I want to insight on the point in discussion with expert here. Thank you.
Thank you so much. And I think that's bringing us almost to one of our first questions we might have in the question and answer period. And thank you very much for your presentation. Interesting that you put the highway up there. And I put a highway up there as well. That was not planned. Thank you so much for your presentation. I'd like now to pass to Dr. Axel Hahn, who will provide us with a bit of a presentation on this maritime connectivity platform to support satellite-based data exchange. Over to you, Axel.
Thank you very much, Gillian. Lovely as ever. And I also thank my colleague Yoshihiro, because I got a lot of things I can take now into my presentation. So thank you very much. And my talk is about business models, the impact of all what we are speaking about in the maritime world. And first, guys, here in the first row, I have bad news for you, because I definitely think everybody needs you, but nobody wants you. Yeah? So what we need and what we want is, we want safe, efficient, sustainable shipping. And yeah, to implement that, let me say what we are doing and what we are speaking about from the user's perspective. And I think a company like MOL or MOL is also taking this user perspective into account. In fact, we want maritime services. So we want to get nautical warnings when we want them, we need them. We want to have a proper and good weather forecast or ice forecast or whatever we talked about already. And vessel shore reporting, all the things as public services. And speaking about business models, we can think about also on commercial services like voyage planning or fleet monitoring or just the delivery and updates of nautical charts or port service and port collaboration. So I see, let me say, something like VDES, like a riverbed. Yeah, so a riverbed, water is coming down, and but what we want is to get our first fighted. Yeah, so and for that, additionally to that, to this riverbed bed, we need to do so and to make it efficient, some kind of water management. So what is the idea of what we need is an efficient implementation, and for that, harmonized platforms I here introduce will help here. And I brought you a story why I can sit here, because I'm not starved as I was a student. Because while I was a student, maybe some I know from Hanno who shared it a little bit. Yeah, I learned yesterday in the bus, is I earn my money by doing smart and small programs, and I used a platform for that. And the platform was Microsoft DOS. Maybe everybody used of you because that was more or less what was the third commercial platform available to make computers available for everybody. And it's not made only computers available for everybody, it provided also a framework for me to write as a student, to write small programs to customers and to earn money with that. And the threshold to do so was extremely small. Just a computer, a little compiler, a little bit background knowledge, and when I'm done, I was able to earn money to pay my small student bills. And so such a platform can offer, let me say, the environment to facilitate it, the services we need, and it makes them accessible for the consumers. So I see platform and platforms as communication platforms as a service is a big business. You see it on my chart here. It's getting very much up. And such a platform is, as Julian already introduced, is exactly the Maritime Connectivity Platform. And the main thing of this platform is, firsthand, to provide trust between the maritime stakeholders. Because if I would like to communicate and rely in safety-critical operations, I definitely need trust to my communication partners. And of course, if I go into waters and I need the services on hand and I have to find them, so therefore we need a service named Service Discovery. So I would like to know where to get proper ice charts from, the best weather forecast and everything, or to even buy some things. And as well, and here of course we team up. That's the important message here is we need a reliable messaging structure. So as a background under it so that we can exchange information in a reliable way. And one of my slides I mostly take into my presentations, and some of you already know it, is today we have a lot of existing technologies. And to be honest, just from the base concept, I think VDES has also a small design flaw because it's not addressing just right from its DNA by design cybersecurity issues. And with AIS 1.0, it was very, very easy, and it's just some euro put into an internet shop to get proper devices, and the MMRs will go up the Oldenburg lock every Wednesday morning. And we have to make sure that this does not happen to VDES and our communication means we are discussing on. So, and it's not only the hardware and not only the communication channel, but it definitely needs also ensure secure, efficient, interoperable maritime services with a proper software. And why I put often this thing here in about security. If we would really rely on a safety-critical operation as shipping is, and it turned out that in this world not everybody is everybody's friend. So what we need if we have a short-to-ship communication, one very important thing is definitely, and we have to provide solutions for that before we roll everything out, is about authentication. We have to need that a message we receive is authentic. That's coming from the sender and it's not altered underway. Because I put the life of a crew and the wellness of a ship on this information if I do that. Yeah? So if it comes to business models, of course, when additional technology is coming into play, encryption. Yeah? So because if you bought something from me, it's okay that only I can receive the information or the person who have paid for it can receive it. So we need authentication and encryption. And as I said, we have to deal with that at VDES as well. Yeah? So we have to think about it now, how to do that. And in Germany, we have a saying on that. If it's something needs some definitely good improvement and little wonder, so what we're saying, it needs some fairy dust. Yeah. So if we take something like VDES and put some fairy dust on top of it, or pixie dust, that people in the UK would perhaps say, is what we definitely is to bring these things together. And what can help, and follow up on your presentation at the end of your presentation, is, okay, we have on one hand wider bandwidth activities, and we have VDES-based things. And my vision here, I would like to propagate here, is we should think them as an extension to each other. Yeah, with dedicated means of usage and means of roles we have here. And if we can do that, I think that is an activity we had quite with a contribution of people around the world, and not to mention Sterna doing it, is, for instance, a specific service we are providing, just as an example, with the Maritime Connectivity Platform, is something we name the Maritime Messaging Services. So that we can use different means of transportation. So following on Gillian's slides, getting more away from the coast to switch automatically the communication channel, but maybe already with a broader bandwidth, exchange the public keys and all the information you need. And so then, if we have maybe a little bit bandwidth limited VDES connection, just add on a little bit only with the signature of the messages, and we can make it very, very efficient. So, and one technology, and we already had here examples and hardware on that, is, for instance, the Maritime Messaging Service that is providing some kind of intelligent router. So just where you are, and what we want is to switch the channel and support safe and secure communication. Another thing is here, and more or less at the end of my 2 days presentation, on the other hand, if all the people really work on these things here, speaking in a position as a work group chair in the INAF committee about data harmonization, Stefan from Sternula and I have a message for you, because definitely what's needed, we need some more expertise and work done in, let me say, the ways how to communicate S100 messages as the common maritime data structures into VDES. And this is possible because S100 has specific, we name it encodings, way to store the data very efficiently, not only as XML based, which is they are human readable but quite huge, to store it in a more efficient way and communicate this then via VDES. So here definitely we need your support to do so. And this is just a call to help us, so a little bit homework for everybody. And another thing, on the other hand, is we have seen all these first test beds and experiments with the satellites you launched in, I think, a huge undertaking still today to bring up a satellite. So again, congratulations here from my side. Is we would like to offer a test bed here to bring these things together. So the existing first-hand communication system, existing broadband communication, and I would like to introduce here the Open Digital Incubator Initiative. So we would like to provide an end-to-end test bed for e-navigation or a navigational service and a collaborative test bed here, so that we can verify and validate the first new reference implementations we already get in the first round here a good idea from, and to check if they are feasible, comparable, and cooperating to each other. And so a warm welcome, contact Thomas Christiansen, a lot of people know, or just me, and I can make the link and see how we can integrate your contributions here to make a bigger and better one of all of our things. Okay, my last slide here is, of course, coming back to business models and closing the loop to my starting presentation. So I think all these technologies we're discussing today provide us really also a lot of chances and also a lot of business chances. So as a service provider for here, a platform as a service like Nuffling is doing, an organization a lot of you are members on, or as a service provider, providing your services, your calculations, your weather forecast, your chart updates, your route optimization, your port collaboration to the customers around the world, and use the platform as a service provider, and in the end, so making friends with you again from the beginning, of course we need the satellite communications provider that providing all the backbone that's definitely needed to do what I was just talking about. So, said that, thank you very much, and I would get back to Gillian.
Thank you so much. Very interesting. And thank you for bringing in all those key points there. That S100 over VDES, how do we get to that? The security. We might have some questions on cybersecurity and actually where it resides from that point of view. And this challenge that we have, so you can join the Digital Incubator Initiative and think about how to enter the market. Thank you very much for that. I would like now to pass to Dr. Koichi Yoshida, and he is going to be joining us from London, where he is at the IMO. And I have been told that he's online. There he is. Hello, and it's good to see you.
Hello. Hello, good to see you.
Thank you very much for joining us. And I will pass the floor to you now for your presentation. I do understand you said that the internet may not be the best, so we will see you for a bit, and then hopefully we'll see you again at the end of the presentation.
Right, so my slide, please. Thank you very much for giving me an opportunity for presenting about an idea of development of guidelines on VDES coordination and cooperation in IALA committee. I thank Dr. Hon and for his presentation on the maritime connectivity, and my talk maybe one of the way to enhance the maritime connectivity. I'm Koichi Yoshida, and I invited researchers in Ocean Policy Research Institute of OPRI of Sasakawa Peace Foundation. I'm sorry for not joining physically to this forum. I'm now in London, UK for a preparation meeting with the IMO, International Maritime Organization people, for a big meeting next week. I joined GMDSS development in IMO since middle of 1980s. I started working for VDES since several years ago by joining an OPRI in Japan, and internationally by visiting a Space Norway maybe 5 or 6 years ago. I'm now joining the IALA ENAV committee. Yes, next slide, please. IALA has developed the third edition of IALA G1117 on VHF Data Exchange System overview, and has published it since January this year. This G1117 prescribe various possible use cases of VDES, as shown in this slide. Also, Mr. Sano mentioned many of these possible future use. Thank you very much. OPRI proposed the pink marked items. Some of the possible use may be used under the regulatory framework, such as the SOLAS Convention. For example, dissemination of maritime safety information, MSI, ship-to-ship collision avoidance, communication. The others can be realized in a commercial or business basis. For example, fish catch certificate and autonomous ship and operations. Next slide, please. Thank you. VDES is a VHF communication system and may have some limitations, such as communication distance and communication channels and the communication timing. Operation of some VDES system, including ships and land-based stations and the satellite, have been realized, and some more is planned for realizing the various use cases as presented the first session of this forum. In order to realize such use cases and then extend the communication distance and the capability, cooperation and the coordination among VDES systems, such as Stellar system or Japan's consortium, are anticipated. Next slide, please. Yeah, this figure shows some examples. The upper one, an example would be such that a ship under the VDES system A, or such as the Stellar, got linked with the satellite of the VDES system A in the coverage of ground station of VDES system B, such as Japan's consortium. If the system A and system B has a coordination, the communication between the satellite A and the ground station B can be established, and the communication data can be transferred from the ground station B to ground station A through the terrestrial internet network. The other example in the downside would be if the satellite system A and system B has coordination, the communication between a ship of VDES system A and the VDES satellite of system B can be established, and the data can be transferred to the ground station of VDES system A. That is the good examples of the coordination. Next slide, please. Yes, therefore, it is necessary to consider the establishment of an international collaboration on the following point for the establishment of the international cooperation and the resource management of VDES communications, and IALA may develop guidelines for the purpose. That may include, first one is the coverage of the land-based stations and the network. The network should be established, and then sharing resource among the land-based stations and satellite system. Number three, cooperation between the VDES TEL and the VDES SAT, and the cooperation and the resource sharing among VDES satellites. In order to implement the coordination and cooperation of VDES communications, it would be necessary to establish an international organ among interested parties of international cooperation, resource sharing, and the management of VDES communications. Because the communication may include business information, the organ shall not intervene the communication itself, and the confidentiality and the freedom of the communication shall be secured and maintained. Next slide, please. OPRI proposed to IALA in a Committee 28 session in October 2021 a new work item of development of guidelines on the VDES resource sharing and coordination and cooperation. And INAV 28 agreed with this proposal in general. The IALA INAV 30 session and in September last year agreed to include this as a new work item into the next work plan of IALA in 2023 through 2027. IALA INAV 21st session in the January, February this year agreed to start
I do believe that he did warn me that the internet connection may not be as good as he hoped, but we do have the base of the presentation going. And will we be able to get him back again just for this final words? So they're trying to reassess the reconnect with Koichi. I'm sure that we have had a lot of good information already from his presentation. And is that it? He will not be able to come back? Okay. Very good. You do have his presentation here, and he had the opportunity to, unfortunately, I had some questions for him, so we'll see whether or not he's able to join again, but we had the majority of his presentation, and you do have his slides there as well in your packet. You can grab information. So in his absence, can we please thank him very much for his presentation? And actually, that brings us almost perfectly on time for our next session. So I should thank him very much for his internet connection falling down, because we brought us back right on time. Thank you very much. I am also looking on the screen. So for those, good morning, good afternoon, and good evening, please remember to provide your questions online, and we will bring them forward. I do see, and I'm very glad, Koichi, that you were here, because all the questions that came in were in Japanese. So I've been told if a question comes in Japanese, someone will help me out, because I do not speak Japanese. But I would thank you very much for that, and I would like to open the floor to some questions and see if we have any questions. I, of course, have a few ready to go, but do we have any questions from the floor first? Yes, we have a question.
Thank you. I'd like to ask the question for Axel. You mentioned that you are going to launch a S100 over VDES testbed. I'm a digital guy, and I have a simple question, because S100 is based on XML, and generally speaking, the data is a huge amount of data. So is it possible to transmit over VDES such amount of data?
Yeah, that's an easy. Thank you very much. Good question. And if you look at the S100 base document, you already see that there are what's named different encodings. So there's a way a computer stores the information in bits and pieces. And the typical one we're using is XML, because it's human readable. And if you already look at the standard, it has different other encodings. And now the question is simply how we apply it here in the VDES world, how to match it into the AMS and the application-specific messages. And we definitely think that's possible. Of course, not with the XML encoding, but with the other means of encoding, think like HN5 and others, they are named already in the standard. This could be possible, and of course, as everything, it's an undertaking.
Thank you very much.
Thank you very much. While we're waiting for a question from the floor, I'd actually like to jump on that, because it actually goes to something that I've been wondering about for some time, and it's really for the panel, but I will start with Yoshi. There have been so many developments in satellite communications, and you did highlight there about the broadband capabilities that are there. What is the differentiating factor? So what is it that makes VDES something that, as you said, the shipping companies are investing in broadband communications? We saw the change to the Maritime Labor Convention, recognizing rightly so the need for seafarers to have connectivity for their own entertainment, to be able to connect with home. So what is the factor that might differentiate VDE SAT for its use in the maritime industry as a digital communication? So I'll start with you, but Axel, I'll put you on notice as well, and we might go to you.
Yeah, thank you. I honestly say I just standing by the VDES proceeding and preparing the business and quickly. Reason that the gentleman making face, so I presentations have some negative opinion in my panel, but I choose the proceeding VDES. But I'm also surprisingly when talking with my colleague in our parent company in the shipping industry, they are very lack of knowledge for the electronics or digital communications, because the so-called engineer in the shipping industry means driving the engine or maintenance engine, and not the electronics engineer. So I need to the good and easy example or easy profit for the shipping industry or shipping owners to motivate to introducing the VDES and satellite VDES services. And I just want to have the good idea from the stage and an online participant to good idea for, or I can using so or conceive to my colleague and especially my boss to good for the running or go after the VDES in the future, not just waiting for the coming products.
Thank you. Axel, do you have any thoughts on that?
I think Joshiro already answered it.
So I think maybe also we have a challenge then. So we have heard there's a need for the business case. We talked about the business case. What is that that point of difference that we can do with VDES? From what you said, I think one might be that ability to transfer small bits of data, such as engine monitoring information, to provide that in maybe an engine monitoring app that you would have, that you could provide information back and sharing it back and forth from the ship to the shore and then from the shore to the ship. Yes. Any ideas from the floor as well? So we'll go to Lars here in the front.
Yeah. So the answer to your question has been dealt a little bit with during the conversations today. And it goes back to the fact that the digital services that you will benefit from in the future, they will be available over the VDES channel. They may or may not be available over the other technologies. And why is that? That's because the maritime authorities, they cannot rely on proprietary systems that will only be available to a subset of the ships in your waters. They need to be to bring the data, the information out to all the ships, including the smaller fishing vessels, where cost is an issue, where they may not have an IT department that can set up the necessary firewall. So they need to have a very simple and robust system that that can carry the data. So you will want VDES on your big ships, because that is where most of the digital services that are going to be important for weather information. The scalability is much better in this. And then, of course, there can be many use cases where you need bigger amounts of data transported back and forth. And then you can supplement with the technologies that can provide that information. And to combine it, to bind it together, the answer is, of course, the Maritime Connectivity Platform.
Of course. Thank you. So that's that concept of trust. And we have a comment in the back, I think, as well to help add to this. Yes. We could have the microphone over there, please. Thank you.
Thank you. I just want to add to what Lars was saying here is that the other thing with VDES is an open standard. Anyone can build equipment. Starlink and OneWeb are proprietary standards. So that's one element, so an open standard, anyone can build it. The second element is that VDES, with the ship antennas, can handle a lot of pitch and roll and rough weather at VHF. Operating at X-band and KU-band is much more sensitive to the weather of all types. So we will have a more reliable but less capable service, in my view.
Thank you. That comes to my comment, I think, on again, within trust, that aspect of technology being robust and reliable. Did you want to have come back one more time? Yeah.
Yes, thank you very much. The good ideas. So I love the word trust and harmonize and in-time connectivity, and for the VDES keyword. Seaman is used to being the status and not connected continuously on the sea, on the oceans, a long time. So they are enjoying the high-speed internet by the VSAT, sometimes some small area, some Starlink. They are saying that it's a very good service for the high-speed network, also using YouTube, using a Teams meeting with the land officers, but it's a very limited period using. And the basis of some kind of storm, very severe weather conditions, the Ku-band and the high-frequency services are difficult to continue to connect and continuously. But Seaman used to the situation that stopping limited communication is just usually end up safe, but they don't know that what is a strong and well facilitated tool for anytime continuous communication, exchange of data or some communication chat with the ground and other vessels like a VDES. They don't know that are powerful, efficient. So I have to talk a lot with my colleague and in the shipping industry, though, how strong and how efficient to have the trusted data communication in the ocean, anytime, anywhere, even though the North Pole areas, very severe areas. They can use and they can connect, keep the connection with the land and the officer by VDES is good. And I want to say that shipping industry don't just waiting and join the project for proceeding the VDES Consortium in Japan. So developing the good use case for ourselves, for the shipping industry itself, and not only just using the services and just waiting the good service arriving. So developing the new business model or business model in the sea and for in the future for all the shipping industries that have a profit. I said not only just earn profit from the customers or like big car companies or some freight companies, but and the money from the sea data, for example, so using gathering data for the sharing and providing the variable data from the sea.
So I think that that's a wonderful idea to be able to get that data from the sea to share,
yeah,
and to be able to share information. Every ship, imagine every ship, like we have the vessel observation system already with the weather data that we gather from all of the ships, to have every ship gathering all types of other data from the sea. I do believe Axel actually had another comment to add on that.
I have a remark on that as well. So looking around in this room, I recognize, maybe I can say so, most of us are not what we named a digital native. So what we saw in our lifespan is a tremendous change, yeah, for digitalization put on us, on ourselves and our society. And looking on business models and looking on what the changes are in other transportation means, on the road, on the rail, in the air, here definitely we will encounter new business models. Partly they are disruptive, so we will change the way of working, we will change the way we earn money. And of course, in part, it's very good because we have tremendous challenge to face in our society. Yeah, so looking on all the sustainability goals we are facing, we have to address here. And I think digitalization can be part of an answer of that, a part. And I think with providing a good communication infrastructure, we did our contribution to that. So therefore saying that, thank you very much from my perspective here, because I think it is a big cornerstone for changing of the way of shipping in the future, and digitalization will definitely be a game changer in a lot of things. If we speak about future fuels, we future about new ways of energy propulsion systems and ship control, new ways seafarers will work. We will see the world changing here.
Thank you so much. And yes, in many presentations, I've pulled out some work from other areas like the OECD, where they have been identifying that 50% of the jobs that those who are in year 6 or in what we would call middle school, what they will be doing, 50% of those jobs don't exist yet. So how can we provide and imagine a future where we don't even know what that future will be? So it is that digital intelligence. Thank you. Are there any other questions from the floor, please? Are there any questions from the floor? Yes, there is one in the back. Oh, sorry, you have to run all the way up to the back. Thank you.
Thank you very much for your presentations. I really like the way Jillian made your presentation. I need to steal that. I have one question for you. We are a startup that uses location big data. We crunch that in a very high-added way and give that back to the society so people can make very big decisions. We do that on the ground as well. You have lots of cars, you have lots of smartphones, you have drones, you have many, many good things, and you have very profound data in a very dense and big data perspective. Now, we already see on the ground that we want more because the big data can be even better or bigger in quality and quantity. And I think we also have a share of that kind of thought on the marine domain as well. What would be something that might inspire you if you had better or more abundant data? What would you do with it, or what do you think we can do to contribute to you?
Thank you. A very good question. Who would like to take that from the panel? I feel inspired already. One of the things with VDES, I think, is there is a limit to the bandwidth. I am a sailor, but I do know that there is a finite requirement from a physics point of view. A very good friend of mine, Mr. Ross Northworthy, would often speak about the physics and the actual science behind it. But what would we do with more data is amazing. What can we do with the data we have? But I'll pass that question. Any comments from the floor, from the panelists? We'll go one by one.
So thank you for the question from the startups. Yes, I'm not sure my answer is correct or the fit your answers. So yes, I myself very expecting to the born a lot of business chance or some joining a lot of startups for around the Satellite VDES, and not only the Satellite VDES, but data link on the oceans. Yeah. I'm long thinking about shipping industry enjoy the cutting edge technology from the radar and the communication, radio communication on equities, electronic chart. But I think the next is arriving is a data link on the vessels. Data link is very powerful and communicate with a machine to machine, and the data exchange is appear on the world that a lot of chance to realize a new business model. I can't imagine right now. So I'm from the shipping industry. Very want to welcome giving the idea from the discussion about new technologies in the futures. I think, shipping industry needs to change the business model in the future, not only rely on the transporting the cargo.
I think that's a great, and it's almost a challenge back to you. What can you do with a small data packet? Do you have anything to add, Axel? Or?
Yeah, I think discussing the amount of data we can send on is, I think we always should have in mind that there's a physical limit what we can transfer by using radio waves, because the frequency bands are limited in one end or another. So we have to be clever how to use it best in the best way, how we can handle it. And of course, they are very vulnerable. Yeah, so because it's very easy to disturb all these frequencies in various frequencies. It's more or less simple or a little bit more tricky, but this should also be part of our way to explore the potentials of communication on sea. What is, let me say, the way to make it resilient? And as we do it, for instance, in the discussion of R mode and other PNT issues, and my colleague here in our space agency are very keen on that. And we, from the beginning, also have to think about how to make it as resilient as possible, so that we can rely on the things also if they are not available or when they are disturbed. So we have to take care.
Thank you so much, and thank you so much for your question. Does that help?
Well, that was very insightful. Thank you very much. I think the ships can be smarter as an edge device. Maybe that's one implementation, implication from Han-san. And Sano-san, I think your comment inspired me that not just the ship one by one taking advantage of the data, but it's the society feeding back to each individual ships and cooperating, so we have a better maximize social happiness. And I guess that's the next generation thing, and that's a lovely future that we want to be participating. Thank you very much.
And thank you very much for your question. I am looking.
This is.
Oh, 1 second.
This is Koichi.
Who's here? Sorry.
Yes,
you're here.
Back.
You're back again. Oh, hello,
Back again.
Koichi. You're back again.
Sorry
Wonderful.
for the shutdown
yes.
and Wi-Fi in the hotel. I changed the Wi-Fi. Thank you very much. I think although the larger ships and the merchant ships and the passenger ships, and there are lots of data need to be exchanged, like on maritime digitalization or digital twin. But we shouldn't forget about the smaller craft like fishing vessels and pleasure craft, where the very limited communication, but very important communication is required or necessary or wanted, like communication with families or communication with the other nearby vessels. And because the last year in April in Japan, we had a very sad maritime accident happened in the northeast end of Japan, and nearly 26 people lost their life in the very cold water. In that case, the communication couldn't be established. In that case, if this VDES provides some good and the communication track, and in that may be what should be helpful. That we shouldn't forget about the use for the smaller craft cases. Thank you.
Thank you. Actually, that was, I have a couple of other questions I was going to use from the floor, from the position of the chair. It's always good to be the chair to ask questions. But I do see that we are very close to running out of time. But I guess some challenges that we have now that we won't have answers for. I have some questions for everyone to think about. What might be the use case for these smaller vessels for commercial and recreational? And I'm looking to the startups for ideas. And we have small data packets, so work within the physics of what we've got. But what can you do with that capability? How can we have ship-to-ship sharing of information for significant weather events, for example. If I'm on a ship and I experience weather that was not forecast, how can I make sure that automatically that goes to all the other ships in the area so they don't have issues? We've had significant weather events. How can we market the capability of a unique ability to transfer data over the maritime VHF, the maritime mobile band, in a digital manner? So I guess that is a challenge that we leave this forum with, maybe more questions than we have answers. But I would like to close this session out and thank my panelists, and including our gentleman from London who came in just at the end, perfect timing, and to thank you all and pass back to our MC.
Yes, thank you very much for distinguished presenters and distinguished moderator, and thank you again for the productive and fruitful discussion, and also leaving very big homework to all of us, the participants. So now we would like to move on the closing session of this forum. I would like to again introduce Dr. Tomonari Akamatsu, the Director of OPIA ISBF, to provide closing remarks. So Director Tom, please take the floor.
Really, thank you so much for all. And today we have like a really comprehensive review of the VDES system. And also we can see like a future perspective of that kind of system. And that reminds me like a Skyfall movie, or the 007, a little bit further away. And he has kind of small equipment, switch it on. And after 2 or 3 hours, the rescue team to save him. If the VDES system can be like this size, I really hope to put on my life jacket. So anywhere on the globe, I'm going to be rescued. So yeah, that's a dream that I think is feasible. And today, we said 3 objectives. The first is finding allies, and second is share challenges, and the third is exchange idea for future. I think we did it already. But I also see the 2 what to do in the major things. First is the convenient but reliable and also secure communication system. Without that, even completely open system, everyone do not want to use it. And the good thing for the VDES system is the endorsement of the IALA, is the International Government Organization very soon. So that is a data security, but also the open for the use. So that kind of balance is really important. I need your advice for much further away, okay? And second thing what to do is a sustainable economical circulation kind of business model. And by far, most of the government funding supporting for the VDES system construction, but it doesn't last for a longer time. So we need to develop the economically make sense circulation. So why we can use the apps on the smartphone? It is because that is the data market. We are selling our individual information or even environment information to the provider. Provider makes money and feed apps for free of charge. That kind of the circulation will be possible and even easier comparing with a terrestrial system, because in the terrestrial system, we are individual. So the individual information protection will be needed. The European country already established GDPR. And for the stakeholder in the maritime system is relatively small and also much reliable organization. So such kind of data management or data marketing is, I think, very much quickly established in the next next 5 years, I think, until the finishing of the satellite VDES system will be completed. So now we are setting out to a new voyage to like something exploring the digital ocean in the next 5 years. So let us go together. The alliance and the communication and go together is most important thing for the bright future of the VDES system. Thank you so much. And thank you for all for the presenters and the chairs and also the audience in this room and also online on the globe. So thank you so much and see you again.
Thank you so much, Dr. Akamatsu, for your closing remarks. As he said, I'm going to conclude this session. I do appreciate all the presenters, participants, in online, in person, overseas, in Japan, everyone. Thank you very much. So yes, for online participants, thank you very much for watching, and for in-person participants from overseas, please have a safe trip flying back to your country. Thank you.